Hello everyone, welcome back. In our last video, we explored sequential chains where each step in the chain executes one after another in a fixed order. That was great for workflows that always follows the same path. But what if you want your AI workflow to make choices along the way? What if the next step depends on the output of the previous step? Now that's where the conditional chain comes in. So conditional chains lets you design workflows that branch based on certain conditions. So instead of a single fixed path, you can define multiple possible paths and the chain decides which one to follow depending on the model's response or some other criteria. So think of it like you choose your own adventure book. Depending on your choice, the story takes a different direction. Conditional chains give your AI workflows that same flexibility. Okay, let's take an example. So imagine you're processing customer feedback. So if the feedback mentions a bug, you might want to send it to the development team. If it's a feature request, you might want to send it to a product team. And if it's a compliment, maybe you log it and then thank the user automatically. So with a conditional chain, the workflow evaluates the content and routes it automatically. You don't have to manually check each case. The chain handles the branching logic. So the real advantage of a conditional chain is that they make your workflow dynamic and intelligent. So you're no longer limited to linear processes. Instead, your AI can adapt its upcoming step based on the data it sees. Now, this is incredibly useful for real world application where inputs can vary widely, like customer support, content analysis, data classification, and much more. So in this video, we'll implement a conditional chain and see exactly how to set up multiple paths and conditions. So by the end of this video, you'll understand how to create a flexible AI pipeline that responds intelligently to different situations, making your applications more robust and closer to human-like decision making. Now, let's jump onto the code. Okay, I'll create a new file here and I'll call it uh, conditional chain.py. First of all, we'll have our model, then a .env, then I'll have my prompt template, then I will have the pydantic output parser, which will come from LangChain core dot output parsers import pydantic output parser. Then I will use this runnable schema dot runnable import runnable branch for branching chain logic, and then runnable lambda for a lambda function. Since we're using pydantic models, so we'll include a base model and a field. And also, let me write this literal class from the typing function. Load the library, load the model. Okay, now I'll also have one more parser, which is the str output parser. So my parser object will also be created, str output parser. Now I'll create a pydantic class here for feedback. So this will be a base model. I will try to find the sentiment of the feedback, which will have two options. It can be the positive feedback or a negative feedback, and then its detail will be given here, field, and description is the sentiment of the feedback provided. Okay, I will have a parser 2, which will be my pydantic parser or pydantic output parser, and then the pydantic object will be my feedback class. Now I'll have a prompt 1, which will be my prompt template. Prompt template. Its template will be the classify the sentiment of following feedback text into positive or negative, and then this will be my feedback feedback placeholder. So input variables will be feedback, and I'll also have a partial variable because I'll provide a format instruction here. Classify sentiment and provide the response in following format, and then this will have our response format. So I'll have a partial variable. Okay, this has to be a dictionary. So response format is going to come from parser2 dot get format instructions. Okay, I'm going to use a word wrap so that it will be easier for you to view here. Word wrap. Okay, this is my first prompt here. I'll first define a classifier chain which will follow prompt 1, model 1, or the same model that I have. I'll just use the model, and then parser and then parser 2 because I'm going to use the pydantic parser here. Next, I'll again have another prompt which is going to say template write an appropriate feedback to this appropriate response to this positive feedback, and then I'll provide my feedback here. I'll have an input variable. This will be feedback, and I also have prompt 3 that will work for the negative feedback. So negative feedback, and then the value will be prompt 3. So here I'm going to declare a branch chain. As we can see, this is a sequential chain we have here, but based on the output of this chain, now we'll move on to the branch chain and then either select one of these two prompts and then generate the response. Now for branching, I'm going to use runnable branch, not this bracket. I need a small bracket here. So runnable branch, I'm going to declare a lambda function here. So lambda x sentiment equals to positive. So if the sentiment is positive, then my chain will be prompt 2 model and then parser. Else, if my sentiment is negative, lambda x dot sentiment equals to negative, then my chain will be prompt 3 model and then a parser. And I need to declare this as a runnable lambda. Lambda x. So if, else if, and then the last one is else condition here. So if the sentiments are either of these positives and negative sentiment, then I'm going to say no valid sentiment found in my review or feedback. Okay, the bracket should not close here. So this is done. Now what I'm going to do is I'm going to combine these two chains into one chain. So first one is our classified chain, and then the second one is our branch chain. So we can also combine a sequential chain and a conditional chain into one single chain here like this. The first one that is going to be executed is our sequential chain or the classified chain, and then based on the response of that classified chain, we will then move to branch chain, and then the model will work accordingly. So we'll invoke this chain dot invoke. The entry point is the classifier chain, and then in the classifier chain the entry point is feedback one, or sorry, prompt one, where I need to provide a feedback here. So let me provide a feedback and then say that the phone is actually amazing. Let me print the result and see what we get here. It should actually trigger prompt 2, and then we should get an appropriate response for this positive feedback here. So let's run this. So now we see that we get a positive response, and then there are the model classifies this feedback as positive, and then based on it, it generates a response. Now I'm going to change this. Okay, the phone is actually horrible, the UI is stuck, and then things like that. The UI is stuck, and then if I run this, so the model is in fact giving out a lot of things, but you know that we can structure the output using the pyrentic output parser or this or like we can base it on some form of schema as we've already done earlier. So you can actually implement it yourself. So here we get that the response, okay, so it says that when responding to negative feedback, so it classifies the feedback as negative here for this thing. So in this video, we saw how we could implement conditional chains using runnable branch, runnable lambda, as well as how we could combine a sequential chain and a conditional chain into one, and then make our workflow automated here. So I hope this runs on your end. This is all for this video. If you have any queries, feel free to comment down below and I'll try to help you out, and I'll see you in the next video.